Okay, so in this video I'm going to show you how you can import shapefile data into Blender using the Blendergis add-on. And I'll put a link to this GitHub repository in the description. But once you're here, you can go over to the releases section and then you can download this version here, 2.28. This is the one I'm using. It works with Blender 3.2. And once that's downloaded, you can go over to Blender, go to Edit, Preferences, and then move over to the Add-ons tab here. And then in the Add-ons tab, you can press Install, navigate to the place where you downloaded the add-on, and then press this Install Add-on button. And then you just need to make sure that you check this little box to actually enable the add-on. And if you've done it correctly, you should see a GIS menu pop up here with options available to you in the menus. So the dataset that I'll be using for this tutorial is the London Data Store London Atmospheric Emissions Inventory for 2019, emissions data for London. And if you navigate to this file here, this the one that's 66 megabytes, you can download the emissions data GIS files. And once that's done, you can navigate to the folder where you downloaded it. You can right click on that emissions summary data, and I'm just going to extract it to this folder. And then you can see that you get 3 folders as a result of that, and I'm going to select this one that has Shapefile SHP, and I'm going to extract that. And then that will give us a folder called SHP, and in that folder we've got all of the shapefile data that we need. So now we can go back to Blender and we can start to import that shapefile data. And first of all, I'm just going to delete this lamp, and I'm going to delete this cube, but I'm going to keep the camera there because that might come in handy later. So before we import our GIS data, we can import a base map which will provide a reference for that data. So I'm going to go over to the GIS menu, I'm going to go to Web Geodata, and I'm going to go to Base Map. And I'm going to select the source as OSM, which is OpenStreetMap. So you can see here that we get a 2-dimensional view of the world, and you can zoom into this map using the scroll wheel on the mouse, and you can also pan using the middle mouse. But there's a quicker way to navigate to a specific location, such as London. If you press G, you can type in the name of a city, and then I know that the zoom level that's good for this data is 12, so I'm going to type in 12, my zoom level. And then if you press OK, you can see that it takes you straight to that city. And then to export this map into the 3D space, I'm going to press E, and then I'm going to use this navigation widget here to orbit in 3D space and just check that the map's in place. So before importing the shapefile data, one thing that's quite useful is to change the navigation settings, the default settings that come with Blender. So if you go to Edit and then Preferences, you can go to the navigation section, and I like to enable this orbit around selection. I like to enable depth, that gives a sense of depth underneath the cursor, and I'm also going to enable zoom to mouse position. Just makes the controls a little bit more intuitive. So now to import our shapefile data, we can go back to the GIS menu. We can go to Import and we can choose Shapefile. Then we can navigate to the location where the shapefile data was downloaded. I'm going to click on this Shapefile SHP folder, and in there we have got a number of different files relating to emissions, and I'm just going to select this top one here, which is CO2 grid emissions for all sources. I'm going to click on that, and then I'm going to click on Import SHP, and you can see that this box pops up, and I'm going to use the default option here, geometry. I'm going to select extrusion from field. Field that I'm going to choose is the all 2019 field. I'm going to extrude along the z-axis, that's good. I'm going to have separate objects for each of the data points, and I'm also going to select this option here, object name from field, and the field ID that I want to use again is 2019, and I'm also going to press the cross here and disable this scene georeferencing option because I don't really want to use it right now. And then finally I'm going to press OK. So you can see over here in the outliner that the data has been imported, but there's nothing visible in the viewport, and that's because it's outside of the view range of the camera. So one way we can see that data is by using the scroll wheel to zoom in, and we should see the data emerge. But also another perhaps more safe way to find that data is if you go over to this side panel here, expand that, and then go to the View tab, you can set this option here, clip start and end, And if you increase this end value to something like 10 times the value, so if I put times by 10 in here, that's asterisk 10, then you can see that the whole thing becomes visible. So if I zoom into this data a little bit using the scroll wheel, you can see that it goes very far off the screen into the sky. So what I'm going to do is I'm just going to scale it down a bit. So in order to scale, I'm going to press S on my keyboard, and then I'm going to press Z to constrain it to the Z axis. And that's just going to bring the heights of all of those data points down a bit. You can also use this scaling widget here to scale the heights of the data points. But the nice thing about using the S shortcut is that you can set the distance from the center of scaling, so it gives you a little bit more fine-tuned control. And so now we have the shapefile data imported into Blender. We can click on the individual data points, and if we go over here to where it says item and expand this panel here, which is properties, you can see that we have information relating to that data point. So you can see here that this is CO2. You can see that we're dealing with tons per year, and you can see that the total for 2019 was this value here. And if you click on some other points, you can see that they relate to different parts of London. So this is Bexley, this is Barnet, this is Kingston, and this is Sutton, etc. And so what we can do now is we can give this data a material and a color so that we can visualize the height of each of the data points. And to do that, I'm just going to move my cursor here to the gap between the timeline and the 3D viewport, and I'm going to click to drag and move that area up. And I'm also just going to shift the viewport here so that my data is within view. And then what I'm going to do is I'm going to go back over to the timeline here, and where this little clock icon is, I'm going to change the function of this viewport to the shader editor. And this is going to allow us to apply shading to our objects. So what I'm going to do is I'm going to select one of the objects, and then I'm going to press add new to add a new material to it. And then if you zoom in, you can see that these are what are called nodes relating to the material. They're defining the material. However, we won't see updates to the material because currently we're looking at this in a kind of flat shaded mode. So up here, I'm going to change the shading to material preview. And you can see that that has a subtle effect on the way that this looks. And so for instance, if I were to change this base color value for this object, you can see that it changes the color of that data point. But what I want to do here is I want to apply a color gradient to the length of this data point so that it goes from one color at the bottom and in a gradient up to a different color at the top. And in order to do that, we need to get some extra nodes into this material graph. So what I'm going to do is I'm going to press the shortcut Shift A, and I'm going to search for texture coordinate. And then I'm going to click on texture coordinate, and then I'm going to click again to set that down. And then what I'm going to do is I'm going to click on this node output here where it says generated, and drag, and you can see that plus icon comes at the end of the cursor. And if I release, it will ask me to search for another node. So I'm going to search for the separate XYZ node, and then I'm going to click to place that down, and then I'm going to drag off from this Z node here, and I'm going to release, and then I'm going to search for the color ramp node, and then I'm going to click to place that down. And then finally I'm going to connect this color output node into the base color of this principled BSDF node. And you can see that what that's done is it's given a gradient to that data point with black down at the bottom and then white up at the top. And what we can do is we can add color stops to this node. So I can press this plus icon to add a new color stop to the gradient, and then I can change the color of that stop. And then I can also move that around, and I can move the stops to the different sides of each other, and so I could invert that direction. And you can also change the interpolation between those colors, so you can change it from linear to constant if you want to have like a sharp cutoff for a certain color, and then move that around. Or you can use one of these ones like ease or linear to map your colors to the height. So this is good for this data point, but we want to apply this gradient to all of them. So in order to do that, we first need to select all of them. So I'm going to go over to the collection here, right click on it, and then go to select objects. That's going to select all the objects in the collection. And if you see that light orange outline, it means that it's the active object, and that's what we want. So I'm going to press Ctrl L, and then I'm going to go to Link Materials, and that's going to link all the other data points materials to this one, so that they all have the same material. But now we can see that there's a slight problem because the mapping of that gradient is relative to the height of each object. And really, to get a more objective reading of the heights, we want to map it to a constant height level. So in order to do that, I'm going to use a reference object to scale the gradient for each of those objects. And so to create that reference object, what I'm going to do is I'm going to hold down Shift and I'm going to right click on the map here next to this data point. And then I'm going to press Shift A and I'm going to go to Empty and then Plane Axes. And that's going to create a kind of null empty object. And on this scale, it's very, very small, so I'm going to need to scale it up. So I'm going to go over here to the item properties and I'm going to change the scale to 10,000. And what I'm going to do is I'm going to click and drag on all three of these fields and then release. And then I'm going to type in 10,000. And that's going to change the X, Y, and Z value at the same time. And so now you can see that the object has become a bit bigger. And if I change over here to the Move widget, I can move that upwards and then just put it next to this data point here. So now what we can do is we can change the mapping from generated to object. So first of all, I'm going to remap this output from this texture coordinate node. I'm going to click on object and drag it into separate X, Y, Z. And then I need to select that empty object as the input for the texture coordinate. So I'm going to click on this little eyedropper icon here, and then I'm going to click on the empty object. And you can see that what that's done is it's mapped the color based on the position of this empty object, which is really nice because now it means that we can use that as our kind of driver for where the mapping of this is. So I can position it up and down, and I can also scale it. So if I change over to the scaling widget here, I can scale it on the Z-axis and change the mapping of those colors. And I was thinking that it might be nice to be able to see the map a little bit through the data points. So what I can do is I can add some transparency into this shader. So again, I'm going to select one of the data points. And to do this, we're going to use a transparent shader. So I'm going to move this material output over here to the right. And I'm going to press Shift A. And I'm going to search for Mix Shader. And I'm going to click, and I'm going to place that Mix Shader on the noodle. And then what I'm going to do is I'm going to search for Transparent BSDF, again using Shift A. And then what I'm going to do is I'm going to connect the output of this transparent BSDF to the input of the mix shader. And I'm just going to tidy these nodes up a little bit so that they make a bit more sense. And now we have a transparent input, so we can hopefully see through it. But you can't see through it yet because there's an option that we need to enable, which is here in the Options tab. We need to set the blend mode to alpha blend. And you might also want to disable this option here, which is show back face. And that's going to disable the visibility of the faces which aren't looking towards the camera. So now we have a slider here in the mix shader which we can use to change the transparency of those objects. So I might set it to something like this perhaps. So in order to render this view of the data, I need to set my camera to the current viewpoint that I have now. And in order to do that, I can go to View, Align View, and then I can go to Align Active Camera to View. And what that will do is it will snap this camera object here to wherever my viewpoint was when I pressed that option. But you can see now that we can't actually see anything through this camera because of the view clipping limits and the size of the scene. So I'm going to go over here to the object data properties, and I'm going to set the clip start and end to something much higher. So I'm going to set the start to 100, and I'm going to set the end to 1 million. And this is in meters. Because we're dealing with a very large area, we're dealing with an area the size of London. And then what I'm also going to do is I'm going to go over to View, and I'm going to select this option here, which is Lock Camera to View. And that means that when we navigate in 3D, the camera is going to follow us. So if I were to click on one of these objects, one of these data points, and move around, you can see that the camera moves with us. And I'm just using the middle mouse, clicking and dragging here to do this. So now if I go to Render, and render image, you can see a rendered image of that viewpoint. But you'll notice that it's a bit darker, and that's because we don't have any real lights in our scene to illuminate this. So what I'm going to do is I'm going to click on this collection here with the camera in, and I'm going to go to Add Light, and then I'm going to add a sunlight. And over here in the light properties, I'm going to set the strength to 3, and then I'm going to press render again. I can see here that I've got some lighting, but it's a little bit stark and it's a little bit top down. So what I'm going to do is I'm going to rotate that lamp a bit. So I'm going to move it using this widget so that it's in view. And then in order to see the effects of the lighting in real time, I'm going to shift over to the viewport shading type rendered here. And that will give me an idea of what the render is going to look like in real time. So if I change to the rotate widget here, I can just rotate that light slightly so that it has a little bit more legible in terms of the shading. And then once I'm happy with that, I can go back and press render. And you can also select your camera, and you can change the focal length here. So I might want to make my camera a little bit wider, and then also zoom it in as well so that it's closer to the data. And I might want to reposition it in a slightly different location. So I might want to be looking straight down on the data, or perhaps looking from the other side. The best way is generally to sort of select an object in the middle and then orbit around it to change the viewpoint. So you can kind of set this up and position your camera wherever you want it to be relative to the data. Okay, so just for fun here, I'm going to select my sun lamp object, and I'm going to scale the object up by a factor of 1000 so that we can see the direction of the light more easily. And then I'm going to go over to my render properties here, this tab, and I'm going to change the render engine to cycles. I'm going to enable GPU compute, so I'm going to use my graphics card to render, and I'm going to turn on this option here, which is denoising, and I can use this to simulate the light falling on the data. And I can also change this opacity value here, maybe make it a little bit lower, and we can use that to render shadows and light falling onto the data points. So that's how you import a shapefile into Blender using Blendergis.